Hello. I thought we would look at solving a second order ordinary differential equation of this form, d squared x by dt squared plus 3 dx by dt plus 3x equals 1. Now, I've chosen this particular equation because it's of the form of d squared x by dt squared plus k dx by dt plus kx equal to 1. Now, these kind of equations are always equal to 1. Now, you could solve the equation on the left-hand side here um, um, by first finding the complementary function when this left-hand side is equal to 0, and then finding the particular solution um, by reintroducing the one on the right-hand side. So you would have to choose complementary solution of A and then substitute it in, and you would then find your general solution. But I think there is probably a simpler way of solving this equation, which I'm going to call this equation dagger. Um, and that is by use of the substitution. Let's go back to this more general equation. So for this more general equation, you would choose a substitution of x equals u plus 1 over k, because when you substitute this back into this equation, including all its derivatives, so we've got x dot equals du by dt, and we've got x double dot equal to d squared u by dt squared, we get d squared u by dt squared plus k du by dt plus k times, and we know what x is, it's u plus 1 over k equal to 1. And then of course we can multiply everything out in this general ordinary differential equation to get d squared u by dt squared plus k du by dt plus ku plus 1 equals 1. And lo and behold, you can see that that 1 cancels with that 1, leaving you with, and I'll write this in green, leaving you with a simpler equation, d squared u by dt squared plus k du by dt plus ku equals 0. And that is a lot easier to solve. That is in the more standard form of linear ordinary differential equations of second order when they're equal to 0. So let's go back to the original equation that we want to solve. So let me just write down the equation again. So we've got d squared x by dt squared plus 3 dx by dt plus 3 x oops, let's just get rid of that little scribble. Equals 1. Right, okay, so what are we going to use for the substitution? Well, remember, For the general equation of this form, providing it's equal to 1 on the right hand side, you use x equals u plus 1 over k. If k, whatever the number k happens to be, whatever the value it is, you write that value down there. So if k is 10 in both cases, then you'd have x equals u plus 1 over 10. If k is 4, then you'd have x equals u plus 1 over 4, and so on. Now in our case of equation, let me just go down here, equation dagger, we've got k equals 3. So what we want to do is to, if we just scroll up a little bit, we write x, or we let x equals u plus 1 over 3. This implies that dx by dt equals du by dt, and d squared x by dt squared, it's getting a little bit cramped here, is equal to d squared u by dt squared. Because as you can see, with that being a constant added on to the u, the derivative of u plus that constant, which in this case is a third, the derivative of u plus 1 over 3 just becomes du by dt, and then the second derivative is d squared u by dt squared, because constants always differentiate to give 0. So we can rewrite, let me just, I'm going, oops, right, call that, that's our equation dagger. Right, it's a bit of a, we'll leave that there because it's easy to identify. Right, so substituting in d squared u by dt squared for d squared x by dt squared, we've got d squared u by dt squared plus 3 du by dt plus 3 times u plus a third equal to 1. So let's scroll down a little bit. This simplifies to give d squared u by dt squared plus 3 du by d, let me just, dt plus, if we multiply this bracket out, we get 3u plus 1, because 3 times a third is 1, and that's equal to 1. And straight away, you should be able to see that, let me just, right, okay, so that cancels with that. You just subtract 1 from both sides, leaving you with d squared u by dt squared plus 3 du by dt plus 3u equals 0. Righty-ho. Now then, let me just go a tad there. How do we solve? Well, we call this equation dagger, or 2 dagger anyway. We'll call that. Right, now, just click on the black pen again. Right, okay. So the way to solve this equation, dagger dagger, is to substitute. Well, we need to find the auxiliary I think that's the correct spelling. Auxiliary quadratic equation of dagger dagger. That's not really brilliant. Let me just of dagger dagger. Right, so we do this by substituting in u equals a e to the m t. U equals a e to the mt, so that u dot, that's du by dt, is equal to a m e to the mt, and u double dot, that's d squared u by dt squared, is equal to a m squared e to the mt. So if we just go back to dagger dagger, this equation here, we've got d squared u by dt squared, but we know that that is a m squared e to the mt. So we've got a m squared e to the mt, and I have to refer to the equation again because I forget, plus 3 du by dt. Well, we know that du by dt is this term here, a m e to the mt, so times a e to the mt, plus 3u, but we know what u is. It's a e to the mt here, so we've got 3a e to the mt equal to 0. And let me double check that equation. Yes, so we're all right. Now you can see from this equation that we can cancel the a's and the exponentials, leaving us with, and I'm going to write this in green, let me see, I wanted a thicker green than that. Let me just, oh, that's it, right, so we'll have that green, leaving us with the quadratic equation, or the auxiliary AQE of m squared plus, oh, I see I've made a mistake somewhere there. Let's just go back a minute because I've missed out an m in the above line. So you remember I said u dot is equal to a m e to the mt. Well, that's supposed to be u dot there, and there should of course be an m in there, leaving us with an auxiliary quadratic equation of m squared plus 3m plus 3 equals 0. Now, this cannot be factorised, or not very easily anyway. It turns out it's complex, and I'll explain why that is. AQE, complex AQE, right. Okay, so if we'd seen how to factorise it, we could have done it in just a couple of steps. But if you try to factorise it, you end up just having to use a quadratic formula. So the quadratic formula is m equal to minus b. Well, minus b, b is plus 3, so it's minus 3 plus or minus the square root of b squared, so it's plus 3 all squared, which is 9, minus 4 times 1, so it's 4ac, so 4 times 1 times 3. In fact, what I'm going to do is, for the benefit of the video, I'm actually going to write this 9 as 3 squared, so that there's no ambiguity, and that's all divided by 2a, where a is 1. This would be your a term here, this is your b term, and this is your c term. If you're at this level with ordinary differential equations, you should know how to use a quadratic formula and what all the terms mean, which is why I haven't gone into it in too much depth. So anyway, it turns out that on the bottom we've got 2. Now this is easily simplified, so we have m equals, I'm going to split it up a little bit, minus 3 over 2 plus or minus, well, this turns out to be 9 minus 12 over 2. So we've actually got 2 values for m. There's a positive one, but of course this is complex because 9 minus 12 is minus 3 over 2. So m is equal to minus 3 over 2 plus the square root of minus 3 divided by 2. And that can be, in fact, actually we'll keep both plus and minus signs in that. So we've got m equals minus 3 over 2 plus or minus the square root of 3i over 2. Right? Because let me just, without clicking this too much, we've got minus 3 is equal to 3 times minus 1, and that's equal to the square root of 3 times the square root of minus 1, which is equal to root 3 times I being equal to the root of minus 1. So that's equal to root 3i. Okay, so I'm going to write down, I'm going to separate these solutions like I attempted just a couple of lines earlier. So we've got, and I'll write these in green. So m is equal to minus 3 over 2 plus or minus the root of 3i, and actually we want to delete one of those. Right, let's just go back up here. So, and m equals minus 3/2 minus the root of 3i/2, right? So two values for m. So we know that for these standard sort of equations, for d squared x by dt squared plus a dx by dt plus c x equals 0, the solution is something like a equals a e to the power of mt plus b e to the power of m minus mt. So we know that's a kind of general solution. This also, if complex, comes out to be sinusoidal. Sinusoidal if m is complex, or it's certainly got a sinusoidal component. So what we can do is, using these two solutions, we can write down that, let me just leave a bit of space there. So we know that, let's go back to that, we know that x is equal to a e to the minus 3/2, I think that's minus 3/2, plus root 3/2i, root 3/2i, plus b e to the minus 3/2 minus root 3/2i. And actually, I forgot to put the t in, so let's put brackets round those and round that. Now this can be simplified a little, if you can actually make out my handwriting up there. So we've got x equals a e to the minus 3/2 times e to the root 3/2 it plus b e to the minus 3/2t, should be a t there as well, times e to the minus root 3/2 I t there. So we've got, in actual fact, I have made another mistake there. Do you see what I've done? I'm writing down the equation for x, but in actual fact we want the solution for u. So let me just erase that, and that. So we've got u there and u there, because that is the solution so far to equation dagger dagger so far. So if we just go back, there we are, it's a solution to that so far, except that it needs tidying up. Now u is equal to, we can take this this term out of the brackets. So we've got e to the minus 3 over 2t in times in brackets a e to the root 3 over 2it plus b e to the minus root 3 over 2it. Oh, let me just right. Okay, now I'm just going to change colour because let's have a yellow. This bit in brackets is effectively sinusoidal or cosinusoidal or a combination of both. So we can make the reasonable assertion that u is equal to e to the minus 3 over 2t times a cos, whoops, we don't want a big square root sign there, do we? So we've got root 3 over 2 t plus b sine root 3 over 2 t. Oh dearie me, that's not looking very convincing, is it? Let's just go back and make a bit more space. Plus the fact I'm getting used to this pen. B sine root 3 over 2 t. Right, okay. So we're nearly done. Now, if you remember, I right back here, I said let x, I highlight it, let x be equal to u plus 1 over 3, right? So we have to rearrange that for u now. So let's just write this in green. So we know, we know that x equals u plus 1 over 3. So u equals x minus 1 over 3. If we substitute that expression for u back into this partial solution, we get, and I will have to scroll back up in a moment, but we've got x minus 1 over 3. Let me just raise that up. So x is equal to e to the minus 3 over 2 t times, in brackets, a cos root 3 over 2 t plus b sine root 3 over 2 t. I just need a steadier hand for this. There we are. I'm just going to double check that. And we're nearly there, but we just rewrite this as so x is equal to 1/3. So we add 1/3 to both sides of that equation. Plus e to the minus 3 over 2t times a cos root I can do it perfectly this time. And that is a solution. So there you are. We have solved, just to conclude, we've solved an equation of the form d squared x by dt squared plus k dx by dt plus kx equals 1, and obtained this solution. So the actual equation that we solved was d squared x by dt squared plus 3 dx by dt plus 3x equals 1, to which the solution is that. Okay, well, I hope that's been of help to you again, and I'll see you in the next video. So bye for now, and take care.